Hello and welcome. Here we are. I'm gonna continue LeetCode problems from where we left off the other day. Make it nice and big. All right, we're gonna start with array wrapper. So let's see how far I get here. Array wrapper accepts an array of integers as a constructor. Two features, two instances are added together. It's the sum of all the elements in both arrays. Okay. String function is called comma separated string surrounded by brackets. Okay. Excuse me. Okay. Interesting. All right. All right. I mean, so accepts as part of its constructor. So yeah, I don't use JavaScript too frequently. It's a two-string. Something like this. Value of array wrapper function nums. All right, let's see. JavaScript data members. Let's see. Classes in JavaScript. Okay. Okay. Okay, let's see how about using syntax. Defines a constructor function. Okay, you could use this. Hoisted. Function expression is not hoisted because it's under a bar, so you must define it before using new. Okay, what is hoisting? Even by hoisting. I don't use JavaScript that much. So there's a lot of details that I'm not familiar with. Top of their scope during the compilation phase. Declarations, not initializations. Declaration is hoisted, not the assignment. Define behaves as far-x. Oh, interesting. Okay. Assignment is not hoisted. Okay. Function declaration is fully hoisted. Okay. Why hoist? Assignment. You know, I often wondered about that behavior in particular. That's tripped me out many times. Temporal dead zone until declared. Also hoisted. Okay. Hoisted initialized but undefined. Hoisted but not initialized. Temporal dead zone. Cannot hoist the declaration assignment together in JavaScript. All declarations hoisted. Okay. Okay. Let's so this means usage in JavaScript similar to languages. Variable must be assigned before use. It will be undefined. A line template is executed. Is that fair? Is that fair? Not quite fair. Okay. Okay. Not quite fair. Okay. Okay. Must be declared with a type before use. Using an uninitialized variable leads to undefined behavior if local. Zero initialization if global. The compiler often warns errors on uninitialized use. Okay. So that's UB. Be declared without assignment. If access a variable, it's undefined on error. Accessing an undefined declared variable throws a reference error. Okay, undefined data wasting reference error access y before initialization. Using is dangerous and often results in garbage values. Using a declared but unassigned var gives undefined with let constant throws an error. Access before assignment. Both require assignment for meaningful use. Wasting data behavior make it more forgiving, but error prone. Okay, so it's a bit more error prone. Somewhat more forgiving. Cause wasting sometimes. It's part of declaration and what's the other one? Declaration and assignment. Towards the top. On the other hand, C++ does neither. Not waste. So the error is outright UB and very dangerous. Well, mostly correct. Okay, wasting moves declarations, not assignments in top of the scope. This makes it more forgiving. Accessing the power before declaration returns undefined, not error. Subtle bugs making it error prone. C++ there is no wasting. Initially, there is very results undefined behavior. The program may crash. This is dangerous, but compilers often in such cases. Okay, safety for flexibility with wasting. No flexibility where minus CB is risk. Okay, got it. Thanks. Thank you, Mr. AI man. All right. Anyway, so if you want this dot sum or nums summation, do it that way. JavaScript sum over array, array. I don't have the syntax for that. Oh, that's not what I wanted. How are we doing here? I think I made a mistake. Hopefully you guys can still see me. Okay, this probably should be also nice and big. Is this, yeah, 170 is good. Some integer array, use the reduce method. Okay. Okay. Function, accumulator current value. And define a function here. Okay. Like that. Reduce. Stop reduce. We have accumulator, and then what's this current value? Yeah. Oh, no, stop doing that. I think it just looks like this. So, okay. And then this string or internal string is what I used before. What was this? The internal string. JavaScript join equivalent. Basically, Python has a join that's pretty good that I like to use. How are we doing here? Okay, I think we're okay. Maybe a little bit more like this. Join method. Oh, it's got the same thing. Okay. So we're going to do nums.join. And let me use this character. And then let's say return start summation. Okay. And then the string. And what does concatenation look like? This might be it. I just don't remember a lot of these details. Okay, it looks like I did that right. Template literals. Okay. Oh, right. Not quite right. Can I use this here? Don't recall. I don't remember. Whoops, I should probably close this actually. Yeah, it's going to be really expensive. Not sure if you can see that. Yeah, I don't think you can. All right. What did it do? Okay, I'm going to submit this, see how this goes. I'm assuming this is correct. I don't know. There we go. Not bad. Not the fastest, but not too bad either. Okay. That took me maybe, yeah, it took like 10 minutes, 12 minutes. Took a while. Took a while. 3 integers, x, y, and z representing point positions of 3 people on a number line. X position, person 1, X, Y, Z, 1, 2, person 1, 2, 3, person 3 does not move. 1 and 2 run towards 3 at the same speed. Which person reaches person 3 first? 1, 2, or 0? Okay. All right. Speed. Oh, the same speed. Okay. So it's going to be the absolute value of the difference. Yeah, between X, Y, and Z. Yeah. So it's going to be const val, 1 second, equals the absolute value of XC, say val 1, 2. Let's actually do, yeah, let's do val 1, 2. And YZ, say val 1, is greater than val 2. Else if val 1 is less than val 2. And then there's an outlast else here. All right, so if they're equal, return 0. There's probably a better way to do this, by the way. What did they say? If X is person 1, 1 if they arrive first. 1 and then return 2. There may be a better way to do this, but I'm just going to do it this way. I'm going to go for it. I think this is right. We'll see. Okay, yeah, pretty good. Not bad. How fast is that? That was a couple of minutes. It's okay. Wasn't the fastest, but okay. So shuffle the array, given the array nums, consisting of 2n elements in the form x1 to xn to y1 to yn. Turn the array in the form x1, y1, x2, y2. Okay, so we're going to, it's actually interleave is the right expression. So if it's n is 3, we're going to do 2, 3, 5, 4, 1, 7. Okay, this is so interleaving the array. All right. I'm thinking about it may be better to create a new array. This is actually a merge routine. Yeah, it's better to create a new array. Int salt. It's going to be nums size 0. Let's say std. It's actually probably easier to do it this. I was going to say std copy kind of works, but actually not quite. It's a little bit easier to do it this way, I think. So x1, so it's going to be nums size plus plus I, and start at so we do I plus equals 2. Actually, let's do this way. We're going to write this to the result of, it's going to be I bit shifted by 2, I think. 0, 2, yeah, we'll do I bit shifted by 2 and set that equal to nums of I. And then I 0, I is less than n. Could do the I is n, I is less than n bit shifted twice, plus plus I. There are a few ways to do this, actually. This actually isn't a merge, so there may be a better way to do this that doesn't involve doing it this way. I'm not quite sure, actually. I'm wondering if I swap the x values where they're supposed to be. Oh, that may have been a better way to do it. I'm not sure. I'm not sure. This is probably a little easier for me to think about, I think. I'm actually not totally sure about this. So this is going to be a +1, I think. So we start from, yeah, it's something like this. This was wrong. Do it this way. It's a little bit confusing, I think, trying to express it exactly the right way. I think this works. Let's see. Wrong. Okay, we'll get it. So my output was 225511. I did this wrong, huh? Oh, this was supposed to be this one. Yeah, whoops. Yeah, okay. Yeah, not the best way to do it. This might work. Not the best way. Presumably it works. Yeah, it's fine. Okay, worked out okay. Not the best. Not the best. There are probably better ways to do that. But that was okay. Okay. But yeah, interleaving the data. Okay. Given a string date representing a Gregorian calendar date in the year, month, day format. Date can be written in its binary representation obtained by converting year, month, and day to their binary representations without any leading zeros and writing them down in year, month, day. Let's just see what time it is. Okay, about 20 minutes in. Binary representation. Okay, binary representation of date. Okay. Excuse me, is there a simple C++ routine to convert to binary? I don't remember if there is one or not. I could write a lambda expression, but it seems unnecessary. Let's see what comes out. Maybe I will write one actually. I'll just write a lambda. To bin. Oh yeah. And we're gonna say false. I think there's a better way to do this too. Just gonna say if x equals 0. Um, is this correct? If we did 5, no, let's do 4. So divide by 2, you get a 1. Divide by 2 again, you get another 1. Divide by 2 again, you get another 1, remainder 1. No. 4 remainder 0 is 0. 4 remainder 2 divided by 2 is 0. This remainder is 0. 2 divided by 2 is 0. Remainder 1 remainder 0. Oh, right, okay. And then you reverse. Yeah. Okay. Okay. What the remainders are. Yeah. Okay. It's a bit confusing. So we're gonna say x divided equals bit shift 1. And the remainder is a character. It's something like this. It's something like this. I'm not sure. Okay. I'm not gonna make it a const. See if that compiles. It's something like that. Okay. I think there is a built-in that gives you the. I think there's a built-in that gives you the binary representation. I just don't remember. Oh shit. Sometimes the LLMs just are annoying. All right. So So there's like std to integer or something like this. We're gonna say C++ split is not the most obvious as well. I mean, we can do something like the following. I'm gonna say position equals what's this? Date.find. And we're just gonna say int position 0. And then we're gonna say result ret. So ret plus equals to bin of this character. Yeah, do that a couple times. So from previous. We're gonna say date dot substring. There may be a better way to do this. There's probably this. Previous to position. There's definitely a better way to do this. And yeah. This is not the best way to do this. Sure. Bit set. Okay. Okay. Find first nav. Okay. Direct binary output. Okay. So use a bit set and find the first that doesn't have a 0. That's probably better than using the 2-bin function. I'm going to maintain the 2-bin function though for now. So give me 1, 2, and then the date is the last one I actually want to have. This is not the fastest code, huh? Not the fastest code, not the best code, not the fastest to write, none of that. None of that. And then it's going to be previous to, I think just to the end. This is quite the code here, huh? Okay. Oh, there's no sub. Oh, yeah, substrate. Yeah. probably a bit awkward to look at. 2 integer. I think it's like S to A or something. I don't remember. It's been a while. S to I. Okay. String stream. Okay. Array to I. Okay. Save for input validation. String stream made it better. TLE. Oh no. Oh, that's not good. Okay. All right, let's do some debugging. I think, I'm not sure if you do the division first or if you do that afterwards. Just as an aside. I think the remainder comes first. I'm not sure. Yeah, I think it comes first. I don't know. That probably shouldn't matter though. File error. Oh, right. All right, this is taking me a while. $20.80, whole bunch of -2s. Okay. All right. Find. I should probably go CPP ref for this. This is a case where you want to look at the documentation. Oh, not that one. It's close enough. Somebody's. Okay. Begins that position. Okay. Okay. Right. Okay. Let's try that. Wrong. Okay. -2, -29. Okay. Right. Oh. So this is a bit awkward, huh? You know what? Actually, it does go something like this. Ah, that's a bit awkward, huh? Let's do it this way. I have an idea. Let's do it this way. Okay. Yeah. Okay. Maybe this is more what I need. Okay, 2080 and just 2222. O2. So that's better. We got two. That's better. Um, Maybe I gotta do something more like this. There we go. Okay. And it worked. Okay. That's pretty awkward, huh? Yeah, that's very awkward. Do I just go for? I just go for it. I'm sure there's a mistake here somewhere. Very high chances of mistake. Oh no, I got it. That's right. Let's see if we get 100% here. Curious how fast this is. This took me a long time to program. This is not the best way to do this. Yeah. It's kind of error prone. It's definitely on the slower side. This is definitely not the best. It's one way of doing it. I wouldn't recommend this, but you can do it this way. Okay, a better way to do it, as mentioned, would be to take converting it directly to. So first things first, you could run the same routine with a string direct. Let's see. Let me see here. A bit set of the number. What if the C++ value is already a string? Example 229. String representation. All right. Let's see what the LLM says. I think actually I could run the same routine that I already had, just using the string a little more directly. No, it doesn't work. No, it doesn't work. It doesn't work. No, no, no. No, you've got to convert it to an integer, and then value is going to be string.x. Then constants string in string. It's going to be, what did they say, bit set? And then we're going to return what did they say? binary find not first of position, find not first of. Take the substring. So it's going to be yeah, probably you can do this. Okay. So this is going to be pointer not equal to string end. Here we would just return 0. And here we would return the substring. Something like this is probably an error there somewhere. What did they say? Commit to an integer, commit to a binary string. Erase. Oh. Well, there you go. It's a little easier, huh? All right. Fair enough. Maybe erase a little bit better. How do they use find not first of? Whoops. Whoops. Gosh darn it. Oh, it is find first not of. Find first not of. Okay. We're doing on time. Yeah, it's taking a while, huh? It's not a pointer actually. I don't know. Positions more like. String studs. Okay. And actually, the erase was a little bit better. Yeah, well, this one's going to take a string now. Mm-hmm. L value. Does this return R values? Oh, that's maybe why. Is that why? Oh, it is why. Oh, that's interesting. I wasn't expecting that. Did it work? Much faster. Okay. Let's try something else. Let's do, as mentioned, let's just do race. Bin string race 0 to first not of. Like that. How about this one? Yeah, I liked how the other suggestion was before. Also the camera's a little bit off here. Yeah, it still works. It's pretty good. Yeah, I'm spending a little more time on this question because I think it's interesting. Like, oh, it wasn't quite as fast this time around. Give it a moment. It's a little bit cleaner, I think. Okay, it is fast. It's fine. It's a cleaner approach, I think. This part's a little bit peculiar, though. This part is a little bit odd. Date find the dash previous. The first position is going to be up to the dash, and it's going to be previous to position as long as we're not off the edge. Then we get that portion of the date, and we add that to return. We also add a dash, and then we actually move the previous to one past where the dash is. And then we look again starting from that point, and then for the next dash, we update the position of the dash mark. And we do that a couple of times. And then we know wherever the previous is, which is going to be past the position, we can just take that to the end. And our binary or 2-bin lambda expression is pretty straightforward. Convert the string to an integer, convert that to a bit set, convert that back to a string, and then erase the zeros in front. I'm sure there's a more efficient way to do this. I bet you there is. More clever way to do this, but this is probably. I bet you could do it. I think you could do on the string itself directly. You can perform the division by 2, and you can also perform the remainder. So the remainder check is pretty straightforward. You just check if the last digit is divisible by 2 or not. If it is, the remainder is going to be 0. If it's not, the remainder is going to be 1. And then dividing by 2 is a little bit trickier on a string. You actually go left to right, and you subtract. So from the most significant character, and you subtract, you either get a remainder of 1 or 0, and the number of times you subtract. So you could use like a map. Or just divide by divide, and it's probably easier just to convert it to an integer, quite frankly, actually, for being totally honest with ourselves. You just convert it to an integer, because the first pass is going to convert it to an integer anyway. Yeah, you don't need to do that. You just convert it to an integer. That's fine. This is fine, I think. This actually is probably about as fast as it gets. Converting it to a string, to an integer, then a bit set, then a string again is a bit odd, but I think that's about as good as it's going to get. There may be a better way to do this. Sometimes I kind of have a habit of like just kind of getting intrigued by a question and just kind of focusing on it. All right, let's go to the next one. Oh, MySQL. Okay, here we go. Recyclable and low-fat products. Okay, product ID is the primary key, column with the values, low fats. Yes or no. Okay. And recyclables, yes or no. Okay. So an integer, it's either low fat and or recyclable. Okay. Excuse me, I'm very tired. How am I doing? I still got 10 minutes to go. Okay. I might want to go for like an hour and a half or 2 hours. Okay. IDs of products that are both low fat and recycled. Okay. I think this one's a relatively easy one. So we're going to say selects from tape products with or when, where low fats equals yes and recyclable. I'm not sure if this is what they're looking for. I don't remember the syntax for MySQL. I think you don't use the double equals in MySQL, by the way. It's kind of like a very expressive kind of a language. Wrong answer. Okay. Well, there you go. What's what do I get for the output? Okay. The product ID is what I want. Okay. I think that's it. I'm gonna go for it. It's a relatively straightforward logic, that one. Nice. Okay. Given n by n integer grid accounts of ij is the amount of money the ith customer has in the jth bank to the wealth the richest customer has. Amount of money they have in all their bank accounts. Okay. So it's a maximum over the sum, I think. All right, that's probably pretty straightforward. So it's 50 by 50, and then the values are between 1 and 100. Yeah, I mean, this is kind of straightforward. This is pretty straightforward. All right, so we're going to do, yeah, it's only 100, right? 50 by 100. So, and I'm assuming they don't have negative wealth. Let's do a quick check. Yeah, no, no one's negative. Okay. For const auto and counts result equals to max result and accumulate. Can use here. Speed up in. Can actually do constant summation accumulate. I think this is how you do it. Could be wrong here. Yeah, I think you could do actually, you could probably make this even one line of code. A transform reduce is probably fine too. I might be able to do that. Let me try that, actually. Reduce. Should know how to do that, I think. All right, we're gonna do the transform and the reduce. We're gonna do, it's gonna be counts in, counts and transform. It's gonna be, come back to that. Reduce, it's gonna be plus. CPP transform reduce. Example. And it's going to be the transform. It's going to be const auto turn to accumulate in 0. All right. First, last init, reduce operation, transform operation. Okay. First, last init, reduce transform. Okay. So first, last init, reduce transform. Okay, something like this. So we transform each of those vectors into integers and then reduce. And I might have been able to use something a little bit better with the accumulate. What's wrong? Oh, not plus, but max. I think it's max. Accent. To come back to that. This I think also could just be v0. Instead max. Does the step max need to be wrapped? Okay. It's a function template, not a function object. Is there max function object? Something similar. I guess it's called a functor. I don't have. Is there an overload or accumulate? Or like step B0 step. That's a little bit annoying. Full left. Okay, let's do full left. Ranges. Full left. What about full left? Could I use? Yeah, probably not. I was gonna say, could I use fold left as a functor object? Suppose that I could use also as a functor object. And so okay, that works. Let's submit that, see what I get. Learning about C++, man. It's pretty good. Yeah, full left's a little bit better. let's try one more time. Cool. I like it. I like it. That's a simple one. It's a nebuloid. Okay. Okay, got it. Thank you, Mr. AI man. All right, how are we doing here? An hour. Okay, we'll do like 2 hours. I'm enjoying myself here. Yeah, like kind of improving a little bit here and there. It's like this is more of a raw loop, and this is more of a sort of functional approach. Not functional approach, but more of a how you might use a little more modern C++ for this. Yeah, I like that. I think that's pretty good. I think that's pretty good. All right, let's keep going. Reverse degree of a string. So what did I say? We'll go for 2 hours. Yeah. Calculates reverse degree. Each character multiply its position in the reversed alphabet. Its position in the string 1 indexed. Okay. Sum these products for all characters in the string, return the reverse degree of this. Okay. 148. So you multiply it and add it. Okay. How big are these strings? 1,000. All right. So like 1,000 at the largest, 26,000 times 1,000. Well, it'd be like 1,000,000. Yeah. Okay. So it's gonna fit in. It's gonna fit in an integer. All right. So this is also we could use a transform reduce. So let's do the same thing. It's gonna be stood transform reduce. Let me say it's S in and S end. And we're going to start with 0. And then we have the reduce and the transform. So the reduce operation is going to be plus. The transform operation is going to be the expression. And this is going to take const char x. And we're going, oh, but we don't know the index, do we? No, that's a little too hard. That's one of the things that, is there a way, oh, is there a way to track indexed transforms? Yeah, there's probably a way to do that, but it's a little more involved. I might want to use a raw loop. Yeah, when you're working with things related to indices, it's kind of hard to replace a raw loop. It's kind of annoying, but it's the reality. A lot of extra typing here. So this is the character. And then it's 26 minus this. And then you multiply that. Yeah, something. Using a lambda as a captured index variable, we're going to see instead of the Okay, there you go. Int value index and x plus plus. Okay, you can. Yeah. All right, let's do that. Let's use the transform wrong answer. No. Negative 74. Oh, right. Slightly off here. I'm assuming these are lowercase letters. Usually it is. Oh, okay. Still. I think it's I plus one, but slightly off here. I'm gonna go for it. I'm fairly confident the string is supposed to be lowercase letters. Yeah. So this is how you do it with a raw loop. But let's use the transform. Transform reduce. Back to sing sequence plus here. All right, it's going to be a step in, a step end, 0, reduced plus transform is going to, so we can capture the index of that value. Just current. We'll do char and see that. Okay. So plus plus index return 26 minus x minus times index. Actually, in this case, we're multiplying this by index. X minus a, something like this. So I was wrong. So you can capture an index variable, and then that's really cool. I didn't think about that. I like that a lot. I like that approach. It's pretty cool. Nifty. All right. How are we doing on time? So I got a little more time here. All right. Manual index tracking only works with sequential execution, transform over indices. Oh, use index I. Okay. Can use iota. Right. This will work if it's sequential, or not sequential, but it's a parallel. Say for instance, parallel execution. Well, this, you can do it this way. The problem is this is quite a bit slower if you have to copy the indices. Potentially a lot slower. That's another approach. That's interesting. I'm pretty sure I've done that before. Fairly confident I've done that before. Okay. I wonder if something's happened to the chat here. Yeah, you can't really see me. Starting to go invisible here. Start getting darker here. Consistent strings, okay. String allowed. Give a string allowed consisting of distinct characters and an array of string words. A string is consistent if all characters in the string appear in the string allowed. Return the number of consistent strings in the array of words. String allowed consisting of distinct characters and an array of strings words. Okay, so we have allowed characters, an array of string words. A string is consistent if all characters in the string appear in the string allowed. Okay. Okay, and then each of these need to be and then get the number of strings in the array worth. Okay. Could also be a transform reduce. Okay. So you could turn actually there is an easier way to do this. Let's use it. Let's do it this way. So we're going to convert the string allowed to Boolean allowable 26. String fill allowable false. And then we're going to say for const char x and allowed. I'm going to say allowable x minus a is true. And now we're going to do returns to transform reduce. And it's going to be words. Words.begin, words.end. 0 plus. And this is going to take each word. String s. And we're going to do return. I guess like all of, something like that. CPP all of. How are we doing with, I wonder about, yeah, the chats, okay. All right, okay. First, last predicate. Is there a concise? And this is going to be similar kind of a thing. Const char x is, this is going to be allowable. Allowable. Okay, something like this. No more Amanda. Okay. All right. Fair enough. Fair enough. And how are we doing? I was gonna do it for 1 hour, but I ended up doing this for a little bit longer. Oh, there we go. I think that's it. I think that's the whole thing. It's pretty efficient. Yeah, it's pretty good. It's a very concise way of doing this. So yeah, transform reduce. We just have an array of bools. And then we say for each word, we're going to add the number, count the number of words by adding. And the transformation is going to be that all of the characters are in the allowable set. Can be found in that array of allowable values. Yeah, it's pretty good. I like that. That's on the faster side. It's probably about as fast as you could do it as well. There may be some slight optimizations here, but that's pretty fast overall. I really don't know actually how to make this faster. Excuse me, it's about as fast as you can make it, I think. You can maybe terminate early, but that probably does terminate early already. That's pretty good. It's reasonable. It's reasonable. Okay. I'm gonna do one more submission. All right. How are we doing on? Didn't see anything from chat. Still an hour and 15 minutes. I mean, yeah, I was gonna do maybe 2 hours. So 40 minutes. Okay, this is okay. All right. The next problem is gonna be. There may be some optimizations here to go even faster. I'm not gonna touch them now. All right. Binary search tree to greater sum tree. Oh, I already solved this one. Yeah, it's interesting. I think I spent a while. What does it say? Is the same as 538. Okay. I already solved it. All right. Original array of prefix or. Integer array, prefix of size n. Find and return the array of size n that satisfies this XOR prefix. Proving the answer is unique. Okay. From this array, we have the following 5, 7, 2, 5, 2, 0, 3, 1. Oh. I think this is just a basic computation. Okay. Yeah, so, I mean, this is going to be the prefix. I mean, yeah, prefix. I think it's like initial sum or prefix sum, partial sum. That's what it is. So we can do std vector and result. So, oh, it's XOR. Yeah, yeah. So that's exclusive scan for prefix sum operations. I think the one that they wanted is inclusive scale. Inclusive scale. Okay. Okay. Begin and result 0. So it's just brief begin and could actually, I think, put it in the same vector, by the way. Come back to that. I think it's that easy. No. Bit XOR. Oh, excuse me. I think it's. Oh, I think I have to go backwards. Oh, I see. That's so confusing. Oh, I see. From the prefix, so we go backwards. Oh, I see, I see. It's still a similar thing, but I should be able to do the. I should. Okay, got it. Just gotta go back the other direction. All right. Result begin. Oh, I see. This is the wrong answer, but it will give me something interesting. Oh boy, I need to plug in the computer. Give me a moment here. Give me just a moment. Oh, you can't even see me now. All right, give me a minute. Be right back. Okay. All right. Okay. Let's think. Right, there we go. All right, is it too dark now? That's like super dark now. Like in darkness now. You can't even see me. I could turn a light on. That may not be a bad idea. I don't know. I think I'll just leave it for now. That's okay. So anyway, okay. So this is one way of using the inclusive scan, but they actually want the opposite. They want think about it a little bit more. They want to go the other way around. So the prefix of the entire array gives me the last element. And that's going to be if you take the previous two and XOR them, you should get this value. Or you should get this too. So all of these values XORed. Give me the last value. Oh, excuse me, if I XOR, all right, so if I XOR all of the previous values at that point with this one, then I'll get a 2. Yeah. And everything XORed up to that point is 3. So I can XOR 3 with 1, and I'll get 2. Okay, and then I can XOR this one with this one, and I'll get the next value, 3. So it's this one, 1, 2, 3, 4. So it's these two XORed gives you 2. Or no, excuse me, these two XORed gives you 2. These two XORed 3. These two XORed 2. These two XORed gives you 7. And then the last value is just okay, that's interesting. We could do something like the following. Can use a transform, I guess. What does transform? Maybe I can use a Hmm. Um. Could do something like this. Something like this. Mm, how about this? One's a bit involved. Begin and input. Yeah, it's just as there could be a binary operation. That's interesting. Okay. 2 input ranges. Oh, that's interesting. So you can kind of zip things out. I'm not sure if this really makes sense what I'm doing here. Maybe a raw loop is better here. Hmm. Oh, it's less than or equal to 0. Should be less than 0. There we go. If I don't have this, yeah, it's fine. We'll just do it that way. All right, let's try it now. How are we doing in the chat here? Okay. Hour and a half so far. Daily check-in. Okay. Doing okay. This isn't the most efficient way to do this, it seems. That's kind of annoying. Oh, there we go. Okay. All right. Not bad. Yeah, that's an interesting question. XOR question. How are we doing on time? 30. Yeah, I was gonna go like 1 hour, but we'll do like 2 hours. Smallest even multiple. Smallest positive integer that has a multiple of both 2 and n. Oh, that's pretty easy. It's just here. You just multiply by 2 and 1. Yeah, if it's odd, you multiply it by 2. If it's not, just return it. I think I could be wrong, but I think that's it. Yeah, that's a pretty easy one. It's like a very easy one. Generate binary strings without adjacent zeros. Okay. And if all substrings of x of length 2 contain at least 1. Okay. Without adjacent zeros? Excuse me. Okay. Turn all valid strings of length and any order. There are only 2, I think. Oh no, excuse me. There's more than one. All right. Oh, there's a bunch. Okay. This might be a dynamic programming question. Okay. So if you have a set of strings that works, either it ends with a 1, in which case you could put a 0 in front. I'm actually, string's a little bit odd. You kind of want like a string stream or something. Okay, for appending, suppose have a strings would be the most efficient character. Would I use string? Maybe I want to do it a few times. Okay, what if I do this a few times? A program. I wonder if I use stream for this. Okay. That's the best way to do this. All right. Let's see. Hmm. Okay. All right. So this is probably pretty fast. Okay. So okay. Maybe some dynamic programming here. All right. It's gonna be initially just empty string. Actually, we can do it this way. It's maybe a little bit easier. Okay. So if const auto string in result. Iteration. Actually, do it this way. Okay. So these are roughly the same size. Roughly twice the size. Okay. So if s dot back is 0, 1, so I can't see the keyboard anymore, it's so dark here. Okay. If the back is a 0, then we're going to say copy plus s, copy dot pushback, a 1, and then we're going to say next iteration. Copy. Or better, we can say place back s, and then next iteration back dot pushback. That might be better. Okay. So if you see a 0, you could put a 1. If you see a 1, however, you're going to do this twice. You're going to push back a 0 and a 1, which is a little bit more involved. These should be characters, not strings. Just kind of a subtle difference. All right, I think that's all we need here. Yeah. I think that's it. That gives us a dynamic programming solution that should work reasonably well. Oh. size the results. Okay. There we go. So we're going to build. Yeah, I mean, okay. When you have a small number of test cases, you can actually just test every test case directly, which is kind of cool. All right, how are we doing? Still have another 20 minutes here. That went pretty quick. A lot of strings. Okay, let's go for it. That might be correct. We'll see. Okay, on the slower side, but correct. Yeah, that's an interesting question. That's basically like a form of DP or BFS, whatever you want to call it. It's not the fastest solution, though. There might be a faster way to do this. Yeah, you could hard code this actually. You could use for this something like this, you can actually use constant expressions because there are only 18 of them. So you can actually do this. You can use template, like basically template meta programming to do it at compile time. And that would be very fast. That's an interesting question. So yeah, being able to do things at compile time. That's probably a situation where a compile time solution is probably reasonable. Okay. Goal parser interpretation. Okay. Interpret a string command. The command consists of an alphabet G, opening, closing parentheses, and or AL, some order. The goal parser will interpret G as a string G, opening, closing parentheses, the string O, and AL as the string AL. What? Interpret strings and then concatenate in the original order. Command, return the goal parser's interpretation of command. Goal G final. Okay. Go. I mean, okay, I guess. All right. Algalude. This is a weird question. There are only 100 characters, so yeah, I mean, this one is pretty straightforward, I think. You just test one, it's 1, 2, and 4 characters ahead. I'm going to use a raw loop for this because it's a bit complex to use a. You probably could use a excuse me. You probably can use a I forgot what to say. You probably can use oh, I forgot. I totally forgot what I was going to say. You probably can use a transform or something like that, but it might be easier to just use a roll to get the logic down. Mhm. So this is going to be if I plus 1. So there's something here. All right. So we're like 2 characters ahead. So I is already less than command plus 1, but I plus 1 also needs to be So it's going to be the substring from the hide I plus 1. I think this works, substring. And then we can do a similar sort of thing. And then same thing here, I plus, I think 3. So I plus 1, I plus 2, I plus 3. That's going to be I plus 3. I think that's about it. Position length. Oh, I see. Okay. So this is not going to be right. So it's going to be 2, 4. Let's try that again. Okay, I think that works. Let's go for it. There might be a slight error here, but I think this is right. Oh, got it. Okay, not too bad. Maybe not the most efficient way to do it, but pretty straightforward way to do it. All right, 147. I'm gonna try to submit one more time. There's probably a faster way to do this, a little bit more effective, efficient. Oh no, it's fine. That works. All right, next. Greatest number of candies. Okay. How am I doing on time? Together 12 minutes. All right. Number of candies the ith kid has and your extra candies. That's the number of extra candies that you have. Give a Boolean array result. It's true if after giving ith kid all the extra candies, about the greatest number of candies among all the kids are false. Multiple kids can have the greatest number of candies. So if I have 3 candies, excuse me, and I add 3, it'll have more than, greater than or equal to. Okay. So that 5, 6 is greater than or equal to 5. So I think I just find the maximum, and then I just say for each of these, if this value plus the extra value is greater than or equal to the maximum, then return true. Okay. All right. That's pretty straightforward. So here it's true. It's 10, true, false, true. All right. Fair enough. I think that's pretty straightforward. So we're going to say, we can use a transform again on this. Oh no, we can't. Max val, it's going to be stood, max elements, candies, candies, end. And we're going to say term transforms, going to be candies in candies to end, result will begin. And it's going to be this. We're going to value here. Okay, capture the max value. There we go. And extra candies. Some constant x. X plus extra candies. I think it's that simple. Let's give it a shot. Let's see how that goes. We got another 10 minutes here. Yeah, it's probably, let's return that one. See how that goes. Yeah, it just has to be larger than the maximum. That's it. Greater than or equal to the maximum. We'll submit one more time. That's a pretty straightforward one. Okay, let's try left and right sum differences. Okay. Zero index integer array nums, size n, define two arrays, left sum and right sum, where left sum elements from left of the index I and the array nums, there is no such element. Zero. Oh, excuse me. Left by sum of the what's the right of I. So the absolute value of the difference in the left sum and the right sum. Okay. Left sum 0, 10, 14, 22, right sum 0, 3, 11, 15. Okay, that's interesting. It's peculiar, huh? I mean, yeah, you could keep it simple and do prefix sums. I think these are exclusive scans. Excuse me. So we'll do left scan. Right scan. That's kind of awkward. Yeah, let's do it this way. So we'll do nums. Left scan and right scan. Size nums. Okay. Now we're going to say I'm just going to 2 different lines. All right. And then exclusive scan. So left scan is begin and the right scan is reverse begin. And we're going to write to left scan begin 0. And we're going to write to right scan reverse begin 0. Okay. And then we're going to say transform turn nums. We're just going to write directly into nums. It's going to be left scan begin, scan end. So binary operator. right scan. I think reverse begin or also begin. I'm not sure. It's gonna be B. This is an awkward one, huh? Oh, appears to be correct. Okay. How are we doing on time? It's almost 2 hours in. Okay. Let's submit this here and see what we get. Okay, I think it's correct. Yeah, pretty quick. I think we're looking at this particular question has a lot of where's the problem statement? There, I want to see the description. There we go. Only has 1,000 numbers involved, so it's very efficient overall. Okay. Not very efficient, very fast overall. Okay, I got another couple minutes. We'll maybe do one more question and then be done. This is an interesting question. Turn the sum of the two integers. What? I've already solved this one, but how is this not the easiest question on the website? Geez, some people got this wrong. Oh no. There's actually some things that could be subtle here, and that's the numbers at larger values. Okay, we'll do one more. That seemed a lot easier than it should have been. N employees in a company numbered from 0 to n minus 1. Each employee I has worked for hours of I hours in the company. Company requires each employee to work for at least target hours. You're given a zero-indexed array of non-negative integers hours of length n and a non-negative integer target. Return the integer denoting the number of employees who work at least target hours. Okay, so yeah, I can use the transform reduce again. As long as the number is greater than or equal to 6. Yeah. So it's going to be hours begin, hours end, initial value 0. The reduction, so this is reduce, transform. It's going to be static plus. And this is going to be transformation. Oops. Of target. And screen target. I think that's it. I think that was very straightforward. How are we doing on time? A little over on time. Maybe we'll do one more question. I do enjoy these. It's satisfying to be able to solve these. Yeah, that one's a pretty easy one. Then on bit flips to convert number. Bit flip number is x is choosing a bit in the binary representation of x and flipping it from either 0 to 1 or 1 to 0. For example, x equals 7, the binary representation is 1, 1, 1, and we may choose any bit, including any leading zeros not shown, and flip it. Flip the first bit from the right to get 1, 1, 0, flip the second bit from the right to get 1, 0, 1, flip the fifth bit from the right leading 0 to get 1, 0, 1, 1, 1, etc. Given two integers, start and goal, return the minimum number of bit flips to convert start to goal. Oh, this is interesting. So you can use an XOR Hamming distance. Here's the Hamming distance. Okay, so if you take the XOR, you get an idea of where the differences are. Or start to goal. So we can use the bit count of the XOR, I think. 7 and yeah, if they're both zeros, you get a 0. If they're both ones, you get a 0. It's only if one is a 1, the other one's a 0. Yeah. So take the bit, okay, bit count, pop count, I think. Bit count in count of 1 bit set bit pop counters. Yeah. I think it's pop count of this. And like this. Step pop count. Okay. Bit set. Step pop count. Oh, that worked. Can I submit that? I can drive. Oh, it works. How about step pop count? Hmm. 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 I think the LeetCode compiler only goes up to 17. Bit set count. Yeah. Bit set count. Let's try that one. Yeah, same deal. That's pretty good. This is a little more portable, I think. The other ones are built in that may or may not be available. Cool. All right, we'll look at one more question. And I think we'll get going here. The permutation difference, okay. Every character occurs at most once in S, and T is a permutation of S. Every character occurs at most once. And T is a permutation of S. Permutation difference defines the sum of the absolute difference between the index of the occurrence of each character in S and the index of the occurrence of the same character in T. Permutation difference. So ABC and BIC between the index and the occurrence of A and S, the index of the occurrence of A and T. Oh, interesting. Okay. Oh, all right. Length is at most 26. Okay. I mean, interesting. All right, let's try this. I have an idea. Greater than S. Well, let's do occurs in T. Starting to get real tired here. Um, I'm sure there's a better way to do this, but I'm going to use this for now. Mm-hmm. Oh, it's the absolute value of the difference. Yeah, it's absolute difference. Okay. X and Ix, I think. Yeah, occurs in T of Ix. T of X. Let's try something like this. I'm getting tired. Mm-hmm. Oops. Okay. Appreciate that I can reset the layout like that. Um, yeah, I'll fall asleep. Mm-hmm. Yes, it's not quite right. This is also transform reduce, I think. Oh boy. Okay. How about this one? No. Hmm. I may have, yes, I may have missed something. Okay. That's probably it. Let's try it. Yeah, it's good. All right, I'm tired. It's time to sleep. So thank you for watching. We're over 2 hours now. Got a good number of questions in though. That was fun. If you like this kind of content, then yeah, give me a like, follow, subscribe, all that stuff, or like, comment, subscribe. Thank you for watching. It's time for me to go to sleep. Okay.